So our next section, 3.5, we're going to talk about implicit differentiation, inverse trig functions, and then inverse functions. This video will cover the first two topics. Okay, so before we actually get to the differentiation, we're going to just talk about explicit and implicit functions. Okay, so everything we have done so far have been explicit functions, okay, which just means that they are y equals or f of x equals. So they're all the y is solved for, okay? So all the derivatives we've done so far, we've been finding the derivative of y in terms of x, and they all have been explicitly written as y equals. So here are three examples when I'm talking about f of x equals, y equals, and f of x equals. So right now, pause the video and go ahead and find the derivative of these three functions using all the rules that we've done before and simplify your answers. Okay, so once you've done that, here are the three problems done out, each color obviously. Okay, so the first one I have the product rule, and then after I do that, okay, I think it's easiest, once you do the product rule, you have one term, two terms. So what can you factor out of that? You can take out 2e to the x times x minus 3 to the third, and that's what you're left with, and then you can simplify. Okay, so we need to get better at simplifying our answers once we use product rule, quotient rule. So after the product rule, you're always going to look to factor out. Okay, the second one I can't simplify much because there's so many levels of the chain rule being used. Okay, so the first thing is you're going to bring that 3 down, and you're going to change it to sine squared. You could have the 2 on the outside. And then I have times cosine of the same quantity, and then finally times the derivative of the inside, which is 2x. And then the last one is just your rule of a to the x. Okay, so it's the exact same thing times the natural log of the base, which is 5. Now on your quiz, a lot of you did not put this in parentheses. It's confusing. If you have a negative sign and you have no parentheses, it looks like minus. So you want to get into the habit of putting like negative sign or negative cosine in parentheses when it means multiplication, and then finally times 2x. All right, so let's get into the new part. So those were all explicit formulas. Now, implicit formulas is when y is not solved for. Okay, so here are three functions or formulas that are not written as y equals. Now the first one, hopefully you're saying, well, hello, I can just solve for y. So yeah, the first one is pretty easy. You could just solve for y and then you could find the derivative. The second two you can't. If you look, there's no way to isolate y when you have y to the fourth and y. Okay, and the third one, same thing. I have xy here and I have cosine of y. So there's no way to solve for those. So implicit differentiation is when you can't solve the equation for y equals. So you're going to use this, okay? That's all I have down here. Here's the idea of it. You're going to differentiate the equation as it is with respect to x, and then you're going to solve your answer for y prime, okay? The notation I just want to remind you about. So y prime, remember, is the same thing as dy dx, okay? They're both meaning, though, a derivative of y with respect to x. I'm going to use y prime. Sometimes dy over dx is used, but they are the exact same thing. Okay, first problem. So we want to find the derivative of x squared plus y squared equals 25. Because it's not solved y equals, I'm going to do it implicitly. Okay, so you're going to go regularly. The derivative of x squared is 2x plus, now when you get to the derivative of y squared, you have to think that's really, you're going to use the chain rule anytime you have a y. So the derivative of y squared is going to be 2y times the derivative of y, which is y prime. Now, why do you not have to do that with x? Because the derivative of x is 1, because we're finding the derivative in terms of x. Okay, and then equals derivative of constant is 0. Now all you have to do is solve for y prime. Okay, so isolate y prime, and then I have my answer. So I would have 2y, y prime equals negative 2x, divide by 2y, and I'd have y prime equals negative x over y. So there's my derivative. Y prime is equal to negative x over y. So now your derivative is going to be in terms of x and y, because the original equation was what? In terms of x and y. Okay? Next example. So I want to find the derivative of this function that's not written explicitly. So the derivative of x cubed would be what? 3x squared. So nothing's different there, guys. That's the same. Derivative of y cubed is going to be now 3y squared y prime. So derivative of y cubed, the cubed is the outside function, so I do that first, and then the derivative of y is y prime. Okay, and then equals, now when I get to the next term, 6xy, I actually have to use the product rule with 6x and y. Okay, so when I go to do that, the derivative of 6x is 6 times y plus the first function, 6x, times the derivative of y, which is y prime. So that's using the product rule. And then finally, plus the derivative of sine is cosine. Okay? So the 6xy term, I use the product rule with. Now, I want to solve for y prime. So I have two terms that have y prime in them. So I'm going to collect those on one side of the equation. So I'm just subtracting this to the left. And I'm going to leave the 6y plus cosine on the right, and I'm going to subtract the 3x squared. Okay, so you're just bringing all of the terms that have y prime in them to the left, so then you can factor the y prime out. So then I'd have 3y squared minus 6x equals 6x plus cosine of x minus 3x squared. And then finally I can just divide by that quantity, and I have y prime. Okay, so that cancels, and there's y prime. 6y plus cosine of x minus 3x squared all over 3y squared minus 6x. Okay, so finding the derivative, you have to remember every time there's a y, you're going to use chain rule with y prime. And then once you've done the first step, you need to just solve for y prime. Okay, next problem. So looking at sine of x plus y, now you're thinking the outside function is sine. So the derivative of sine is cosine. Leave the inside the same. Now times the derivative of the inside. Derivative of x is 1. Derivative of y is y prime. So there's the left side. Equals, now y squared and cosine of x, I'd need product rule. So y squared would be the first function. Cosine of x is the second. So derivative of y squared would be 2y, y prime, times the second function, which is cosine, plus the first function, y squared, times the derivative of the second, which is negative sine x. Again, I'm going to put this in parentheses so it doesn't look like a minus. Okay? Now, in order to solve for y prime, I have to first distribute the left side. So it's this quantity times these two terms. So I'm going to have to actually distribute the cosine of x plus y. So I'd have cosine of x plus y, okay, plus y prime cosine of x plus y. Why am I doing this? Because I have to get y primes together. In order to do that, I have to first distribute. And then equals the right side 2y, y prime cosine of x, plus y squared times negative sine of x, which really will just turn minus there, okay? So now if I underline which terms have y prime in it. So this term, that's one term, okay? And then I have my 2y, y prime cosine. Those are my two terms with y prime. So I'm going to bring those to the left. I'm going to leave the first one there. And I'm going to subtract the 2y, y prime cosine of x. And then the right side would be this, which is already here, which is negative y squared sine of x minus subtract the cosine of x plus y. Okay, now I can factor out the y prime on the left side. So I'd have cosine of x plus y minus 2y cosine of x equals the whole right side again. And then your last step is going to be to just divide by what's left to get the y prime alone. Minus 2y cosine of x, divide, they cancel on the left, and there's my answer on the right. Plus y minus 2y cosine of x. Okay, again, your derivative is in terms of x and y, okay, because the original function was. So I'm just going to keep saying the steps. Find the derivative. When I do that, I need to remember y primes everywhere there's a y. Then I want to collect all the terms that have y prime, factor out the y prime, and then divide. Okay? Next one. You think you can try this one? Pause it. Pause the video and go ahead and try it on your own, and then you can check yourself. Okay? So, derivative of x to the fourth would be 4x cubed, plus derivative of y to the fourth would be 4y cubed times y prime, and equals the derivative of 16 is 0. Okay, now this isn't that bad. There's only one y prime. So I have 4y cubed y prime equals negative 4x cubed, and then divide by the 4y cubed. So I'd have negative 4x cubed over 4y cubed. So my answer, would just be y prime equals negative x cubed over y cubed. Okay? Now there's the first derivative. This is asking, if you look closely, for the second derivative. So now I would just have to find the derivative of that. Okay, what rule would I use to find the derivative of that? Correct? I know you all just said the quotient rule. So if I go and do my, second derivative over here, y double prime, using quotient rule, derivative of numerator. Okay, remember Hannah, it's the derivative of numerator first. So it would be negative 3x squared times the denominator, which is y cubed, okay, minus the numerator, which is negative x cubed, times derivative of denominator, which would be 3y squared times y prime, y prime, okay, all over the denominator squared. So all over y cubed squared. Okay, now I can simplify that a little bit. I would have negative 3x squared y cubed plus, because I have minus a negative, okay, so it would be plus 3x cubed y squared y prime all over y to the sixth. Now I know that y prime from before is negative x cubed over y cubed. So my last step would be to plug that in. So I have my second derivative just in terms of x and y. So y prime is negative x cubed over y cubed, all over y to the sixth. And then you can simplify that last term. So you'd have what? Negative 3x squared y cubed. Now it would turn into minus, because I have that negative again. So it would turn into minus 3x to the sixth, okay, over what? Y over y, so I could write that as y to the negative 1, all over y to the sixth. And then I could cancel my y's in each, or I could leave it. I could factor out a y, but I'm just going to leave it like that. Okay, so I have that's to the negative 1 power. So second derivative, you're doing the exact same thing for the first derivative. Then you just do it again. And your last step is wherever you have y prime, you're actually plugging your first derivative in, so that your answer to the second derivative just has x and y in it. Okay, next one. Go ahead and pause it again. You can try all these. You think you got it down, okay? So here we go. Square root is the outside function, so I'm going to have 1/2 2x plus y to the negative 1/2 times derivative of inside, which would be 2 plus y prime. Okay, derivative of 2x is 2, derivative of y is y prime. Now when I go to the right side, the derivative of 3 is 0. And when I go to do the second term, I have to use product rule. So I would have 2x times y plus x squared times y prime. There's your first step. Okay. Now again, on the left side, you're going to have to distribute this in order to get the y prime isolated. Okay, so I'd have to distribute that times the 2 and then that times the y prime. So 1/2 times 2 is obviously 1. So I would just have 2x plus y to the negative 1/2 plus 1/2 y prime times 2x plus y to the negative 1/2 equals 2xy plus x squared y prime. Okay, now collect the terms that have y prime in them. So let's see, this and this. I'm going to collect to the left side. So I have 1/2 y prime 2x plus y to the negative 1/2 minus x squared y prime equals 2xy, and then I'm going to subtract this over to the left, minus 2x plus y to the negative 1/2. And then I can factor out the y prime on the left and divide by what's left. So I'd have 1/2 2x plus y to the negative 1/2 minus x squared equals the right side to the negative 1/2, and then I would just divide by that quantity and divide by that, so my answer would be this, to the negative 1/2 minus x squared. Okay, once I divide both sides, so I'm dividing, guys, by what's left after I factor out the y prime, and there's y prime. Okay. Next problem just has a e to the xy in it. So when I go to do the derivative of 2e to the xy, I'm going to have what? E to the 2xy times derivative of the exponent. So derivative of 2xy, I'd have to use product rule. The derivative of the first function, which would be 2x, is 2 times the second, which is y, plus 2x times derivative of y, which is y prime. And then equals derivative of x squared is 2x plus derivative of y squared is 2y, y prime. Okay, left side I need to distribute. So I'd have 2y e to the 2xy, okay, plus 2e to the 2xy xy prime. I just distributed this, equals 2x plus 2y y prime. Okay, and now I want to collect my y primes. So again, I have two terms that have y prime in them, so I'm going to collect them to the left side. So I'd have 2e 2xy xy prime minus 2y y prime. Okay, so all I did was subtract that over, and it's going to equal 2x minus 2y e to the 2xy. So what will y prime equal? Let's see. If we can just skip, I'm going to skip showing factoring it out. So you would have the right side divided by what? 2e to the 2xyx minus 2y. All I did was factor out the y prime and divide by what was left. Okay? All right, now we have an equation of tangent line. Okay, so that's a circle. Find the equation of the tangent line. What's the only difference? So you still need to find the derivative. Okay, so the derivative is 2x plus 2y y prime equals 0. So there's no difference in that. We've already done this problem earlier. Okay, and I can solve for y prime. And when I do that, I get y prime equals negative x over y. Now when you go to find the slope of the tangent line, instead of just plugging x in, you're going to have to plug x and y in. So the slope of the tangent line is going to be negative 3/4 because I'm going to plug 3 in for x and 4 in for y. And now it's the same thing. I have y minus my y value equals my slope times x minus my x value. That's no different. It's just to get the slope, you're going to have to plug x and y in. Okay? So 8's really similar. You need to find the derivative of that function, and then you need to plug in 3. So 3 for x and 3 for y. I'm going to just go ahead, you could take a second, pause it, do it. You should get y minus 3 equals negative 1 times x minus 3. Okay, so you should get negative 1 for the slope when you find the derivative and plug 3, 3 in. Okay, and then this last part I'm going to do tomorrow in class. So just come in, we'll go over this last question. At what point in the first quadrant is the tangent line horizontal? You should be able to answer that, what you're going to do, but I'm going to do the actual algebra tomorrow in class.